Okay, so the first most important setting I would say for producers is Acks. And Acks means acknowledgements. So let's just do a deep dive. We saw in the theory section that there were 3 levels for Acks. There was 0, 1, and all. But I want to give you deep dive insights into how these things work. So Acks equals 0, as you know, is no response is requested from the broker. And so if the broker goes offline or an exception happens, we won't know and we'll lose data. So here's how it looks like in a graph. We have the producer and we have the broker 101, which has one partition for now, and it's a leader of that partition. So the producer sends data to the leader, but because Acks equals 0, well, the broker will just do the writes, okay? But it's useful basically when it's okay to potentially lose data. As you see, the broker does not give a response back to the producer. So the producer really never knows if the message makes it to the broker or never knows if the writes actually happened. So it's useful when you have metrics collection. When you send a lot of metrics, it's okay to lose one metric once in a while. And it's okay when you have log collection. It's mostly okay to lose a line of log. Obviously, it's not great to lose data, but Acks equals 0 really is nice on performance because the broker never replies to the producers. So here's a use case. Now the default as of Kafka 2.0 is Acks equals 1, which is leader acknowledgement. And so basically the leader response is requested, but there's no guarantee of replication. Replication is something that happens in the background, but it's not a prerequisite to receiving a response. If an ACK is not received, then the producer may retry. And so here's what it looks like. We have the producer, we have the broker, and the broker sends the data to the leader. And the leader says, yep, I got the data and I'm going to write it to disk. Here it is, here's your response, and the writes happen. So in the writes happen, then the response is given to the producer. And yes, that's it. The producer knows that the broker has the data. So there's certainty of this. But if the leader goes down, before the replicas have the chance to replicate the data yet, then we'll have a data loss. Okay, so this is one of the most common mistakes I see because it's a default and people are not aware of it. Sometimes there's data loss just because Acks is equal to 1. So now there is Acks equals to all, and it's basically saying, I want the replicas to acknowledge. And so the leader and the replica this time are requested for acknowledgement. So here's a more complicated example. We have broker 101, 102, and 103, and they all have partition 0. One is the leader, it's 101, the rest are replicas. And so as you can see, the partitions are exactly the same because they're replicas of one another. Now the broker sends the data to the leader, right? And the broker says, yeah, I got it. And then it sends it to the replicas through the replication process. This is simplified, but it sends it to the replicas. The replica says, yep, I got it. Here is an acknowledgement for you, leader, that we have indeed gotten the stuff and wrote it to our log. So the leaders acknowledge, which is what's called Acks equals all. And then when the broker has gotten all the acknowledgements from all the replicas, hence the name all, it will send a response to the producer and say, you know what, we're good. Everyone got it. And so basically, as you can see, it added a bit of latency because now for the producer to get a response from the broker leader, it needs to wait for all the replicas to do their replication. So there's a bit of latency added. It's not that much, but you have to know about it. And obviously, because you add latency, you also add safety because we have requested more guarantees now. And so this process guarantees no data loss if you have enough replicas online, obviously. Now, it's a necessary setting if you don't want to lose data, okay? And you have to know about it. So when you have a safe producer, Acks is always equals to all. Now, basically, when you do Acks equals all, because it's not complicated enough, you have to use another setting called min insync replica. And this is a broker and or topic setting. And you basically, if you set at the broker level, you can override it at the topic level. So the most common setting for min insync replica is 2. And that means that at least 2 brokers that are in sync replicas, including the leader, must respond that they have the data. Otherwise, you'll get an error message. So that means that if you use replication factor of 3, min insync replica of 2, and Acks equals all, you can only tolerate one broker going down. Otherwise, the producer will receive an exception on send. So this is also a misconception. If you have replication factor of 3 and min insync of 2, then basically your topic won't be working well if if more than one broker is down, for example, 2 brokers. So just so you know this. So you may be confused, but here it is. I'm going to give you a nice graph for you to understand. So you have min insync replicas of 2, and we have our same setup. Now let's assume that broker 102 and 103 are both down. So we only have one broker out of this. We had a replication factor of 3, but only one broker is still online. Now the producer sends the data to the leader, and the leader is going to try to replicate. But this replication cannot happen because the other brokers that were replicas are down. And so basically, the number of insync replica right now is 1. And so what the broker 101 will say is, it will reply to the producer and says, you know what, exception, not enough replicas. I cannot give you the guarantee that the data will be written safely to the cluster. Therefore, here's an exception, not enough replicas. And it is the role of the producer to perform retries up until this write succeeds, okay? So if you want maximum safety, maximum availability, then min insync replica 2, Acks equals all, and the replication factor of at least 3. But hope that helps, hope that gives you some perspective. We'll get to practice this in the next lectures, but for now, all the theory is done, and I will see you in the next lecture.